Hello students. In the last tutorial, I have discussed with you about the concept of animation, and we have seen how we can use the draw function to animate, and we had made a circle which was bouncing back and forth when it touches the edges of the screen. Students, to continue further, in today's topic I'm going to teach you about classes in processing. So that is the concept of creating classes. Okay, and to demonstrate this example of creating classes, I'm going to use the same example of animation. So I'm going to recreate the animation example quickly, and so it will be a revision for us again. If you recollect, we have made there's a setup method. The setup method gets called once in the program when the program is executed or running for the first time, and we have defined some variables, say float circle y, giving it an initial value, and when we made the ellipse was having, say, x-axis to start off with at a constant value, say 50, and the circle y value was there, which was coming from the variable, and the width and the height. So when we ran this example, we saw one circle which was at a still location, and it is one frame here. Okay, so animation is nothing but a series of frames. Okay, and that can be done, that series of frames can be made using this draw function, because this draw function gets called 60 times per second. So if I write up here circle y plus 1, so this particular circle y would get incremented, and I'll be getting a series of frames. Okay, so the output would be like a circle which is moving downwards. Since the background needs to be refreshed or background need to be cleared, so we add a background, okay, and color it every time the draw function is called. So this draw function would be repeated each time it is repeated. Okay, the y value would be incremented. So in this way we were able to make a ball which was a circle which was moving from top to bottom, but when it reaches the edges it was going out. So to trap that, we use an if condition. If circle y, which is getting incremented, okay, it reaches that the edge, which the edge is the height, width and height is 300 by 300. So if circle y reaches 300, okay, then what we said was that we were teleporting it. We're telling that let the circle y value start from 1 again. Okay, so when it reaches the end of the screen, it was starting back again from the top. And if I want it to make it bounce back, then in that case what we did was that we defined one more variable with the name, say, float y speed, and y speed initial value was given to 1, and here we change. So instead of 1, we were writing y speed variable, so it was plus 1 plus 1 plus 1 happening. So when the circle is reaching at the end of the screen greater than 300, what we said was that we were changing the y speed to y speed into minus 1. So the y speed value was plus 1, and when it reaches at the end of the screen it became minus 1, and then the draw function was called. So it was now 299, 298, like this. So it was moving in the upwards direction also. So student, making such applications is not that difficult. Okay, to okay, it's giving me an error. It's saying that size. Okay, I remove something. Yes. Oh, okay, void setup method was accidentally removed by me. Okay, so it gives me an output of going in an descending order also, or going upwards also. It's like a bouncing back thing. So if and when it reaches the up, then again we want to make it bounce it back. So we wrote circle y greater than 0. Okay, if circle y, when it should minus happen is that when circle y value is less than 0, or circle y value is greater than 300. Okay, so with this we were able to get the moving effect vertically from top to bottom. So it could be useful, students, when we are making some images or some sprite to move. Okay, so same way we were changing the y-axis also by writing float circle y, circle x, sorry, x-axis also. Define some coordinates, say float x speed, we wrote again 1, and then instead of 50 we wrote circle y, sorry, circle x, and then here the incrementing happened, of which was not only for x y but also for x. So circle x plus 1, circle x plus x speed. So as the code we wrote for the y speed, we are writing for the x speed also. Okay, and instead of 300 we can write up here the height, and then copy and paste this line, student, and it will be repeated for the x speed also. So then with this we had done with the animation concept. When x reaches the greater than the width, so you change the x speed, and it is greater than less than 0, at that time also you change. So we had we can started off the x speed or something at a value of 20, 30 and 4. So we were getting a circle which was bouncing back. Okay, so student, this was the last example which we have done, and it is very easy to make. Now let me introduce to you something new. The concept is of creating classes in processing, and creating classes would be very important, students, because in your games which you develop for criteria C, it is always better to have separate classes created, but we need to understand with the purpose why we need to create a class. Though I'm getting this output here, okay, but then why the new concept to achieve the same thing? Okay, student, what happens is that actually this topic will take us to the concept of object oriented programming. Is a very interesting and very important concept. Those who are aware of C++, Java, okay, C sharp, these languages are using the concept of object oriented programming. Okay, so there's a bit of theory here before I show you the coding for creating a class. And but student, is very important and very interesting. Okay, the term which comes is called as an object. Okay, what do you mean by an object? Object is something which I can see. Okay, object, like you are an object, I am an object, whatever we see around, say fan is an object. Okay, so everything is an object which we can see. Now every object is having two things. One is called as its attributes, and another one is called as functionality. Okay, which you can't deny is to be, this is the, like, okay, yes, every object has attributes and functionality. Means what? Okay, if you take an object fan itself, what are the attributes of a fan? The attributes of the fan are like the how it looks, the three wings. Okay, and what are the functionality is to rotate and give air. Okay, and there's a task, rotate and give air. So if I take an object, there is a chair. Okay, chairs don't rotate, but chair object is having attributes. It has four legs. Four legs would be the attributes. And what would be the functionality? People sit on the chair. So every object is having attributes and functionality. Sit on chair. Okay. So what happens here is, whenever, now in real world, when you want to make projects, okay, student, say imagine that you are a programmer and you have been given a task to make a project for a college or for a school. So what, as a programmer, what are you going to do? Are you going to just start typing code? Okay, write code like this? Of course not. Okay, a proper technique is that as a programmer you visit the school. Though we all know how the school works, but visit that particular school, okay, and understand the requirements. And how you understand the requirement is that, if you follow the object oriented way, that is, identify what all are the objects in a school. So in a brief, if I just write it down, a school is having student, okay, which we can see, yes, students are there in a school. A school is having teachers, students, okay, non-teaching staff. These all objects contribute into the working of working of a school. If students come, teacher don't come, lesson won't happen. Vice versa, if teachers come, student don't come, then also lesson won't happen. If student teachers come but non-teaching staff is not there in the school, then how arrangements and all would be done for a better convenience for the lesson. So student, we are interdependent on each other. So what you do as a programmer is that you visit the school, identify the objects which are there. Okay, now as we discussed above, take one object. Say you take the object student. Say let's take the object student, and now for the student object, so same old thing, write down the attributes and functionality. These are the only two things which we need to think about, okay, in object oriented programming. What are the attributes of a student? If I ask you, you all are students, if I ask you what are the attributes of you, okay, the attributes is something which is mentioned in your iCard. You all students all have a roll number, there is a name, there is a class, okay, to which you are currently studying in. There could be division, okay, so these are the subjects which you are learning. So these are all the attributes for you, okay. What would be the functionality of a student? Functionality is to attend lessons, appear for the exam. It will not happen that a student takes an admission and he will get a degree. Of course he has to appear for some exam, so there's a task, there's a role that which the student has to perform. So these are would be called as the functionality which a student has to do. So student, what I am noting it down, what I am writing it down, same thing I can express, I need to express it by creating a class. So student, why you need a class? Okay, so fine, till here it is fine. So we have attributes and we have functionalities. Okay, take for teachers. Teach, what would be the attributes of a teacher? Teachers have an ID, some ID is there. Teachers are having, say, salary, they are having some subjects to be taught. Okay, and what would be the functionalities for them? Okay, functionality is to teach, okay, and teach properly, teach the concepts, okay, your like summatives, your checkings and all to be done. Okay, so we also have to do task. Okay, so so there is attributes and functionality associated with every object. Okay, if you look at our example here, student, what we have made in this example, we have made a circle, okay, and the circle is moving, okay, from one location on to the other. So I can, so only one thing which we can see is the circle. So in this example my circle is an object, okay, and what would be the attributes and functionality of this circle which we made? The attributes and functionality is something here. We have defined the x variable, the y variable, okay, the x speed, y speeds to controlling the movement of the circle, okay, and so these would be his attributes. What is functionality of the circle? The functionality which is put in this draw function, that is to move, okay, it's to be like, okay, moving here and there. So it is, that is the functionality which the circle is doing. The circle is not just stilled, so it is dependent. The draw function is holding the functionality, what the circle should do, what task is given to the circle, and the draw function is using the attributes. So if you look at in the examples, every example we have will have some attributes and some functionality. Okay, so with this understanding, student, let's proceed ahead. What we have to do now? Okay, what we have to do now, I have to, now in this example, okay, what I have to do is I have written the program, but this program I would be, now if I want to add rectangle to it, then one way is that define separate variables for rectangle, rect x, rect y, and write the, in the draw function, write the features for rectangle. Rectangle is also moving up and down, it's a separate object. Okay, so right, so I will write it, that's fine. But what happens, things would be too much, okay, clubbed together. For example, if I rect x, I will define same way, or rect y I will define, and then I'll write the code for it. So multiple objects code is in one program. It's something like this, student. If you have a drawer, and if you have a cupboard, in the cupboard there are no drawers, and you put your books, clothes, shoes, everything in the cupboard. Putting things is easy, but when we want to fetch it, say books I want to fetch, okay, I have to go through the clothes and the shoes drawer, or shoes, okay, content also to fetch my books, okay, because everything is put in one place. It would have been so good that we have the cupboard, and the cupboard has drawers, and the drawers are being labeled. We put the books in the books drawer, clothes in the clothes drawer, shoes in the shoes drawer. So the benefit is that whenever I want to fetch say shoes, I'll be not be opening the books and the clothes drawer, we'll just be opening the shoes drawer. So fetching becomes easier. Same thing we want to do it here also, student. Here if I write about rectangle, if I write about some square, if I write the movement part about it, so it's like a cupboard. This one program will become like a cupboard with no drawers. Everything is clubbed in one place. So writing becomes easy, but fetching things, modifying things, I have to scroll to n number of line of code. So why don't we use the policy of divide and rule policy, wherein what we will do is that I will be creating a separate for the object circle. I'll be creating a class now, and I will write up here. I can write any name. I'm giving on a new tab of students. I went here on the arrow sign and typed in their circle, and here I will write class circle. Okay, and what I will do in this class is whatever attribute relevant to the circle, I will use it in that class. So I will cut things from the main program and paste it here. Okay, and paste it here. And then next what I will do is, okay, for the draw features also, I'll remove everything from here. Okay, command X, so everything from here, and somewhere here I will write about the, okay, about the draw thing. So but I'll define with not with the draw function, but I will write like okay, any name, say update, because the circle with this code things are getting updated. Okay, so I'll write your update wherein the circle x speed, y speed and all is happening, and I'll write one more function with the name, say void display, which is doing the work of displaying me the ellipse. So things are now separated, things are divided now. Okay, so we have the class and circle, and all this code is written is relevant to one circle. Okay, is relevant to one circle. If I want to make in my program about rectangle, then I will create a new tab for rectangle and write code about rectangle. So like it's like separate drawers which are being made. Okay, and how now I want to use this particular drawer, then how to use this drawer is that I will go to my main program, and in the main program I'll be creating an instance of this class, because these features I want to use now. For that I'll go to the program, I will write circle C1. With this it's like creating a variable. It is also called declaration. I am defining one variable. Okay, one, it is also, it's an object declaration. Okay, I'm defining one object with the name C1. So whenever I write a class with some variable, that variable will be called as an object means it consumes space. Now whatever is written inside circle, it is known to one member, is known to one person, variable. Who is that one variable? Is this object. This C1 knows everything about what is this circle, or rather this C1 represents this circle. This C1 is a copy of this circle. Okay, it's something like an architect is a building construction architect is making a thermocol copy of the building. Okay, and now, so this circle is like the thermocol copy. Okay, and now when the actual building comes, okay, which consumes space, it takes up space, this C1 is like that actual building, but the actual building is the replica of that thermocol copy. Okay, the design which the architect has made. Same thing here, C1 is the instance, C1 is the object which contains all the information about the circle. Okay, and now using C1 I can access any of these features: update method, variables, the display function. Okay, so what I will do is, this is a declaration part, but with this C1 the internally memory space is not allocated. Memory gets allocated when I write with the keyword new circle. So when I write this statement, student, now a memory is getting allocated, or now C1 is storing all the information which we have mentioned in the class circle. Okay, and now I can use it, I can write in the draw method. Okay, C1 dot update first, update. Okay, so that all the speed and all checking would start, and then finally I'll be having C1 dot draw. or c1 dot, okay, display. I think I wrote display. Okay, so this function would be called multiple times, and say you can, if you want, you can have it command X here and paste it here. Okay, so let's run the program. Okay, I've not closed the class here. Okay, and then display function. Okay, so student, we are getting the same output. Okay, there's no change in it, but what we have done this time is we have defined, we have segregated, we have removed, okay, the burden from the program. Things are delegated somewhere and it is put inside a circle, and just I'm creating the instance of this circle and calling the method. So my main program looks very simple and easy. Okay, so what is the benefit of this? What, this is one benefit, that you are dividing things and not putting everything in one program. The another benefit which comes is that let me add, if I want to make multiple circles like this, okay, with different x speed, y speed, or circle x and circle y. So let me not define now values here. Okay, let us try for one circle. Okay, and say x speed also will not define, y speed also not define. What will happen is that now these values for them will come from the main program. Okay, when it will come, as soon as I create the object, at that time I want to assign some values. What values I want to assign is, what is the, okay, what is this initial circle x. Okay, initial circle x, starting circle x value, what is the starting circle y value, what is the x speed, and what is the y speed. So I want to give it via some parameters. Okay, so I want to pass some, sorry, I want to pass some arguments here, okay, to the circle. So when the circle class is created, the circle class also doesn't know what type of circle, what type of speed, from where it is going to start. It is totally now left onto the user who is creating the instance of the circle class to decide from where, what location they want to start, what speed they want to assign. But these arguments should be accepted somewhere and should be passed on to these variables. And how we do it is that we defined a constructor. Okay, a constructor is similar to a function, but there are some two rules which you need to remember. Constructors don't have a return type, void. As you see in the different function, there's void means there's no return, but we don't write any return type for a constructor, and constructor name is same as that of the class name, same as that of the class name. Okay, and constructor, whatever we write inside here, this constructor is automatically called as soon as the instance of the class. This line is called what? Creating instance of the object. Instance of the class means creating, instance means creating an object or instance. Okay, means which consumes memory. So as soon as the object is created, okay, the first thing to be called is the constructor. So what I will do is that these arguments are coming 40, 50, 1, 1, which I want to pass them to this circle y, circle x, circle y, x speed and y speed. So first, whatever is coming, these values, I need to accept it in my program. So how we do it is that I'll define parameters here. I'll write circle x, comma, float, circle. These are new parameters which I'm defining. Circle y, comma, say float, x speed, and float y speed. Okay, student, now these parameters, okay, these variables which is been created, they are different from these variables. They're different from these variables. Okay, how they're different? They are different in terms of the scope. These variables have a scope within, they are called as local variables, and they have the scope within this particular constructor only. And these variables are global variables, also called as class level variables, and these we are also called as instance variables. And these variables have a scope which is available to all the other methods in your program. Okay, so the values first are coming to these local variables, and I want to transfer from the local variables to the global variables. So how we do it is that to denote, to distinguish which is the local variable, which is the global variable, to the processor properly, because since we are given both at the same names, we proceed with the this keyword. we write this dot circle x equal to circle x. This keyword represents what it says. This circle x which you are talking about represents the instance variable or the class level variable, and this circle x is representing the local variable. So the value which are coming, so 40, it is coming first to circle x, the local variable, and then he's transferring to it to the global variable. So then I write this dot circle y equal to circle y, and say this dot, okay, this dot x speed equal to x speed, and this dot y speed equal to y speed. Okay, that's it. No other changes to be done, student. The function is accepting the values what is being given to him at the runtime, and it will be giving us the output. So when I run the program again, I get the same output here. Okay, my circle is moving across. Now what is the benefit, student, I can do is, since I made a class and things are divided, I can go on creating instance of this class. Means if I want to make another circle C2, one more circle C3, so I can just write C declaration part C1, okay, C2 and C3, and then paste, and we did define for C2, we write for C3. Say I'm going to start like x-axis, circle x, circle y. I'll change the x speed to this 5, y speed to this 2, 3, the speed I'm changing 4, and say it is asking starting from any values I'm random, I'm giving a 30. So student, now things become easy for me. If I want to make 10 circles, I don't have to write 10 times the code. The code is written only one time, and I'm just creating the instance of it and calling the various methods. So c1 dot update and display, same way c2 dot update and display, and c3 dot update and display, c2 dot update and display, c3 dot update and display. Now student, when you run the program, we have created 3 circles. Okay, though the code we wrote only once, so it is like reusability. Design once, make it once, and use many times by go on creating the instances of it. Okay, so when I run my example, students, yes, you can see multiple circles. Then if I want to create hundreds of circles like this, student, that also is possible, that I can create using arrays, okay, which I'll be showing in my next tutorial. Okay, so I hope you understand the reasons behind, okay, the coding and creating a class. Student, is a very important concept. The creating a class is very simple. We are just we are creating a separate template where relevant information to a particular, okay, object needs to be stored. Okay, so please give a try to this tutorial. I will share with you in the class also.